Okay, hello everyone, welcome to the RCNP course. At this part, we're going to introduce the multicast. And about the multicast, let's see the overview. The development of internet applications technologies popularizes video on demand, web conferencing, online games, and other applications. The traditional unicast mode cannot meet the requirements for the bandwidth and the latency. The emerging multicast technology makes servers no longer a bottleneck when multiple receivers access limited server resources simultaneously and saves the network bandwidth. So let's see how that works. If we use the unicast, you can see this is a server, we call it transmission source. And for different receivers, maybe some of them are requiring for the same data or same package, right? So for each receiver, the data source sends multiple packets, and multiple packets are transmitted over the same link. You should pay attention. On this link, we send the same packets for 3 times in this case, and only data receivers receive the packets. So if we use unicast, the receivers can receive it. While if we, for example, this is not receiver, so it cannot receive it. So in this case, if we use a unicast, it's consists of, you can see, from source to different receivers, right? And if we use broadcast means one to all, right? One to all, from the transmission source to each client. The data source sends one packet. One packet is transmitted over a link. All hosts receive the packet. While if it's multicast, you can see multicast is one to a group. You can see data source sends one packet. One packet is transmitted over a link. Only data receivers receive the packet. So compared with unicast and broadcast, firstly, multicast can reduce the workload of the physical devices and the links. And this is an advantage over unicast. And at the same time, compared with broadcast, multicast is more secure because it's one to a group. You should define, or you should know where are the receivers. Not each one can receive the packets. So it can make the data forwarding more secure. After knowing the working principle of multicast, next let's see some advantages and disadvantages of it. Advantages is what we just mentioned. It improves the efficiency, control network traffic, reduce the load of servers and CPUs. It optimizes the performance and eliminates traffic redundancy. Distributed applications make multi-point transmission possible. While the disadvantages is shown here, fast effort delivery, lack of congestion control, duplication of packets, out of order delivery of packets. So from the disadvantages, you can know that actually the main disadvantage point is that we cannot have a good control of the multicast packets, right? And if we want to build a multicast network, the architecture is like this. You can see in the entire network, we could have receivers at each corner. So for the multicast source, how to identify receivers is a problem. It's difficult for us to identify the receivers. And for the receivers, if I want to receive a multicast data flow, or I want to receive a multicast packet, I don't know how to join or how to leave a multicast group. And for the routers, for the network devices, there is also a problem. How to maintain group information, right? To facing these problems, actually we should use some protocols. For the host and router multicast protocols is IGMP. IGMP stands for Internet Group Management Protocol. Since it's a group management, so it can be used to maintain or manage the group information, right? And so after managing the groups, actually the routers and the multicast sources will easily identify where are the receivers. Right? While there is another problem, how to establish a multicast forwarding path. To establish a multicast forwarding path, we should have the multicast routing table. So we should have a multicast protocol actually. And for routers, how to forward multicast data, right? So router to router multicast protocol would be, we call it multicast protocol, right? Intra-domain multicast protocols would be PIM and DVMRP. If we use PIM, PIM have two different modes, PIM SM and PIM DM. PIM SM is a sparse mode, PIM sparse mode. PIM DM is a PIM dense mode. They are applicated into different scanner wheels, and it's based on the how many receivers in the network. And for the intra-domain multicast protocols, it could be MBGP. MBGP is the BGP which are used to transmit the multicast routes, and MSDP. Okay. So after using these protocols, the multicast source will send the packet and to the router. The router will forward these packets based on the multicast routes entries, and then the routers will identify where are the receivers. So you can see the receivers in each corner of the network can receive the multicast packets, while if you are not the receivers, you cannot receive it anymore, right? Okay, so this is about the architecture of multicast technology. And about the multicast, you should know some basic concepts. First is the IP address. Okay, and the full range of multicast addresses is from 224.0.0.0 to 239.255.255.255. While this is the full range, and the multicast addresses in this range can be divided into different parts. First is the permanent multicast address, 224.0.0.0 to 224.0.0.255. Commonly, the IP addresses in this range are reserved for some protocols. For example, OSPF, right? OSPF use multicast to exchange the control packets. So it will have a unique multicast address. And another is a user multicast address from 224.0.1.0 to 238.255.255.255. And for the others are local management multicast address. Okay, you should remember this about the range of multicast address. And for the reserved multicast IP addresses are listed here. 224.0.0.1. This is important. Is all hosts need to receive and process packets destined for this address. So 224.0.0.1 is all hosts. 224.0.0.2 is all routers. Okay, is all routers. And 224.0.0.4 is all DVMRP routers. And .5 is all OSPF routers. .6 is all OSPF DRs, designated routers. .9 is all RIP version 2 routers. .10 is all the EIGRP routers. EIGRP is also a routing protocol. Okay, and 224.0.1.1 is a NTP multicast address. 2.13 is a PIM routers. Okay, here are some commonly used reserved multicast IP addresses. and it's better for you to remember them. Okay, and after knowing multicast IP address, next is a multicast MAC address. The multicast MAC address is in this format, 01005E. And the following part is depend on the multicast IP address. So let's see it. For example, we have a multicast IP address. It's a 32-bit, or 32-bit multicast IP address. And now it's 32 bits, while the MAC address is 48 bit. And for the 48-bit MAC address, you can see the following 25 bits are fixed. You can see here, okay? And the last 23 bits of a multicast IP are mapped to a MAC address. So you can see here how to get a multicast MAC. The first 25 bits are fixed, as you can see here. 0000, 0001, 0000, and 0101, 1110. And pay attention here, the 25th bit must be 0. Okay. And then the last 32 bits, we can use the last 32 bits, 22. And then the last 23 bits is the bit from the multicast IP address. So in this case, we got multicast MAC. But what you can find is that for a multicast IP address, the first 4 bit is fixed because the first 4 bit is fixed. The last 23 bits can be used or can be mapped to a MAC address. So we still have, you can see 23 plus 4 is 27 bits. So we still have 5 bits left, right? These 5 bits. And you can easily find out that no matter what are these 5 bits, it will not affect the MAC address. So we have a word says that one multicast MAC address can be mapped to multiple multicast IP addresses, right? And actually it's 32 multicast IP addresses are mapped to one MAC address. The reason is that these 5 bits will not affect the result of the MAC address. Okay. And the next is a multicast model classification. Based on how receivers treat multicast sources, multicast models are classified into ASM and SSM. ASM is any source multicast, indicates that receivers can only join certain multicast groups, but cannot select specific multicast sources. While SSM is the source-specific multicast, it indicates that receivers specify the multicast source. So for example, in the network where I have multiple sources that offers the same results, so if it's the SSM mode, I can specify which source I want to receive the multicast package. Okay, this is the model classification. And the multicast MAC address corresponding to 225.1.2.3 is asking us to calculate it. So to calculate the results, firstly, we should convert, right? We should convert it into the binary. So you can see first 22 bits of the MAC address is fixed, and the last 32 bits is from the multicast IP, as shown here, and the 25th bit must be 0. So the result is shown here. And if we convert it into the common format, we write the MAC address could be shown here, right? And which 32 IP addresses are mapped to this MAC address? We just need to figure out which of the 5 bits, right? And you can see the results here. The IP addresses in these two ranges have different 8 most significant bits, and they can be mapped to the CM MAC address, right? Okay, so about the overview of multicast, let's see some questions. Which of the following multicast addresses indicates OR hosts? This is OR hosts, so which is A 224.0.0.1. Okay, so that's all for this part about the multicast. Thanks for your listening.